Gay-Lussac's law deals with the pressure and temperature of a gas. It states that the pressure of a given mass of gas varies directly with the Kelvin temperature when the volume remains constant. In order to be Gay-Lussac's law, the volume must remain constant. It'll have the factors of temperature and pressure that are varying throughout the problem. The factors of pressure and temperature of a gas are directly proportional, which means that as one goes up, the other goes up, or as one goes down, the other goes down. Pressure of a gas would be describing the amount of collisions of gas particles with the walls of the gaseous container, and the temperature is the measure of the average kinetic energy of the gas particles. A real-world example of Gay-Lussac's law would be in the summertime and the temperature is increasing, and so the air pressure in a tire would also increase. The temperature outside would have to be extremely high for the tire to explode, but the pressure inside the tire does become greater. So the pressure is going to increase in the tire because of the increasing temperature outside. In order to solve a problem using Gay-Lussac's law, you will have to use the formula. And it's that the pressure 1 over temperature 1 equals pressure 2 over temperature 2. You will have to set up a chart with your pressures and your temperatures. And once you fill in your chart, you have to make sure they're all in the correct units. In order to use Gay-Lussac's law correctly, the temperatures both have to be in Kelvin temperature. So in order to convert, you take your Celsius temperature and you have to add 273 to that value. After that, you have to make sure that your pressure units are both the same, because you can't have different pressure units in the same problem unless your numbers will be off. So your pressure conversions are that 1 atm is equal to 760 millimeters of mercury, which is equal to 760 torr, which is also equal to 101.3 kilopascals. Once all your units are correct and in your tables, you can plug in your numbers into the formula and cross multiply to figure out your missing unit. Now let's try a practice problem. A 30-liter sample of nitrogen inside a rigid metal container at 20 degrees Celsius is placed inside an oven whose temperature is 50 degrees. The pressure inside the container at 20 degrees Celsius was at 3 atm. What is the pressure of nitrogen after its temperature is increased? So when you get a problem and you see what factors you have to set up a table. Since this deals with pressure and temperature, you know it's Gay-Lussac's law. So my table is P1, and then you have P1, T1, P2, and T2. So my P1 is 3 atm, and my T1 is 20 degrees Celsius. But since in Gay-Lussac's law it can't be in degrees Celsius, you have to convert it to Kelvin. So you have to add 273 degrees to 20 degrees Celsius. So I got 293 degrees Kelvin. Then I have my P2, which is unknown because we're trying to solve that, and my T2, which is 50 degrees Celsius, and after I convert it to Kelvin, I have 323 degrees Kelvin. Once you have all of your values, you can plug it into your formula, which is P1 over T1 equals P2 over T2. I plugged in my values down here, and I have 3 atm over 293K is equal to P2 over 323K. After this, I cross multiply, so I do 293K times P2 and 3 atm times 323K. I set that up in the formula down here after you multiply it. Once you have your formulas multiplied, you have to try and get P2 by itself. So you have to divide each side by 293K in order for that to cancel out. So I divided each side and I canceled out these factors. So you had 3 atm times 323K all divided by 293K. So you plug that into your calculator to solve for P2. And once I plugged that in, I figured out that P2 was 3.31 atm. And that is how you solve Gay-Lussac's law.